Hello everyone. I'm Andy from ThinkMo. Now I'm teaching CCIE course. As of today, I'll share some with you. Technology related to CCNA, CCNP, and CCIE. Our topic today is quick look at IPv6 headers. First of all, we need to understand what is an IPv6 header. Some of you may not be clear about the IPv6 header. Then you know the IPv4 masthead. Let's make a brief introduction. It is defined in the OSI or TCP/IP protocols. It has the concept of a network hierarchy. It doesn't matter if it's IPv4 or IPv6. It mainly involves packets. This packet is called an IP packet. IP packets are mainly identifies the datagram at the network layer. The role of IPv6 headers. It's mainly used for identification. Which layer the data belongs to. For example, as mentioned in OSI. Data link layer, network layer, transport layer. Presentation layer or session layer. Application layer. Regardless of IPv4 or IPv6 header. Both belong to the network layer. Now we're going to find out. What are the fields in IPv6? Whether it's IPv4 or IPv6. It has corresponding fields. So what we need to know is the field in its message. What exactly does it mean? What are the specific implications? And then I've got two pictures. On the left is IPv6. On the right is IPv4. First, let's look at the diagram of IPv4. For IPv4 headers, it is 20 to 60 bytes in size. The first 5 mastheads is a fixed size of 20 bytes. So why 20 to 60? Because in the options that we're going to cover later, it may fill in some parameters accordingly. It is used to implement other functions. If we don't have this paragraph, the header is only 20 bytes long. This is what we call the IPv4 header. It has versions in it, head length. This is the type of service. It is used in QS. So it's not much of an introduction. And then we have the total length. So these 3 fields. It is mainly used for packet fragmentation and reorganization. When is shard reassembly involved? On a link. One of my devices can send it in one go. Maximum packet size. The default value is 1500 bit. In general, must be more than 1500 bit. So when the data is sent, sharding may be involved. In that piece, the first field is called the identifier bit. So we're in the whole data transfer process. There's a lot of different data. For example, QQ and WeChat. Taobao these data. The first one is called sign scrambling. It is mainly used to identify the yes. Which packet does it belong to? After cutting. Used to identify whether you belong to this packet we're talking about. The second is the tag bit. There are basically 3 bits involved. One is the R place. One is the DF bit. One is the MF bit. So this is a simple summary of these guys. Some of the parameters in it. It's all about whether to shard or not. The second is after the sharding. That is to say, when the packet is cut. When the first one was sent to you. I wanted to tell you if there were any more. And then this thing. Through the corresponding fields inside. Tell the peer end that this is the case. The third one is called piecewise migration. Segmentation offset is the segmentation that is cut out. It might not have been sent to you in order. Maybe I'll give you the last piece first. Or pass you the pieces in the middle. Maybe because of the network. These pieces may arrive first. It is also possible to cut the fragment first. It's the last one. So how do you reorganize that? It's in the process of cutting. It has the corresponding offset, distance from the first shard, or how much the head has shifted. Let's talk a little bit about the others. It's time to live. This is what we call TTL. It is used to prevent ring. Another one is protocol. System of agreement. It's used to identify what protocol is on the top. For example, the upper layer is TCP data. Again, UDP data. And then there's the test box. Its main function is verification, tamper-proof. And then the original IP address. And the destination IP address. That goes without saying. We've already talked about this option. So in the process of that. Finally, we'll look at IPv4 packets. Its effective narrowness sum should equal the total length minus the length of its head, because its head length is optional. Between 20 and 60. The total length is contained. Size of the entire IP packet. And then subtract the length of its head. We get the effective narrow sum. Next up is IPv6. The IPv6 version is the same as this one. And then there's the traffic class. This is the stream category. The stream category field is the equivalent of the DS field in the common message. It's called type of service. Is the type service field? Then there is the addition of a stream tag to the IPv6 header. But it has no head length. A concept of total length. Stream tagging is mainly a technique applied to QS. QS can be more convenient for us. Classified data streams. So what's the advantage of sorting ahead of time? In this way, the efficiency of data forwarding is faster. That's about the stream tag. And if it becomes necessary, we can explain that. And then there's payload length. Payload capacity. It's the same thing as the total length. And then there's the next header. The next hop. It is the equivalent of the protocol field in IPv4. Identifies the upper layer protocol. IPv6 has upper layer protocols. There's also something called extended header. If there's an extended headshot, the next header is used to identify next header. The next step is hop limit, equivalent to TTL. It is mainly used to prevent rings. The original IP address and the destination address are unnecessary. That is to say, IPv6 packets are very compact. There are 8 fields in it. In addition, the 3 IPv4 sharding fields are removed. The checkbox was also removed. The total length is then replaced with the stream tag. The traffic class and DS field are the same. The 2 versions are the same. And then there's the payload. Effective narrow core. I prefer to think of it as the total length of IPv4 minus the head length. Then there's the next header and protocol. It's the same thing. Hop limit and time to life. Source and destination. That is, IPv6 packets. Be more streamlined. It looks like this. Let's take a quick look at IPv6 headers. What is the composition of its head? First, let's say this is the IPv6 header. Further back there may be an extension header. What we're seeing right now. The IPv6 header is the basic header. There may be some extension headers later. Then the upper layer is TCP or UDP. The last layer is the upper layer of data. If there is an extended header, the next header in IPv6, it identifies the next extension header. You see, if there are 2 extension headers, the next header in this extension header identifies the next extension header. If there is no extension headshot, the next header directly identifies the upper layer protocol. That's all for today. If there are any other skills you would like to learn. Feel free to leave a comment or send me a private message if you're interested in what I'm talking about. Hope to like and subscribe more. Thank you. See you next time.